So ladies and gentlemen, today we are going to talk about transformations on our functions. Remember, a function is when a graph can pass a vertical line test and every x value is only used once. We're going to start out with horizontal and vertical translations. These are also sometimes called shifts. You have to enunciate that really well. So notice all we're going to talk about here, these are all shifts. So when we talk about these, you might see this thing f of x. This f of x represents the parent function. And we are using it because we can do these same transformations on all sorts of different functions like lines or parabolas, which you may remember look like a u, or absolute value, which you may remember looks like a v. If you don't remember those, that's okay. Don't worry, we're going to cover them in a little bit. So our first thing is f of x plus k. So f of x plus k. So you'll have some function, and then after that you'll have a k value. That is going to move your function up k units. Okay? What we're going to do here is we will be adding this to our y coordinates. Because up and down are y directions. You know, you go over x directions and up and down y directions. So when you're going up, you will add that to your y coordinates. So if you have something that looks like f of x plus 3, that will shift your function, whatever you're graphing, up 3 units. Okay, it goes up. So when there's a plus sign, it goes up. The next one, we have f of x minus k. When you have a minus k after your f of x, that is going to move down k units. So that minus afterwards makes it go down. So on this one, we are going to subtract from our y coordinates. So if you have some f of x and you have minus 5, that's going to shift it down 5 units. Okay, so you would take your ordered pairs and you would subtract 5 from all the y values. Then, on our next thing, notice this is a different letter, h. It doesn't really matter what letter, it's standing in place of a number. But this is now inside some parentheses. So if it happens to be inside parentheses moves us left and right. So if we are inside the parentheses and we have a plus sign, that's going to move us left. Now I know that seems weird, so you have to just kind of think about when it's inside the parentheses, it's doing weird stuff. So it's going to move it left. Because you think plus signs would move you right, but it actually moves it left. So to move left, we would subtract. But left and right is not a y direction, it's an x direction, so you would subtract it from your x coordinates. So if you had something like this, f of x plus 2, that would shift us left 2 units. Okay, last one. On this one, we have minus h. So when we have a minus sign in here, that's going to make us go to the right. And to go to the right, we would add to the x coordinates. So if we had something like f of x minus f of x minus 8, that would shift us right 8 units. Ignore that, I started to write the wrong word. Okay, so after the x, if it's added, you'll go up. After the x, subtracted, down. Inside with the x, plus is left, minus is right. Okay, so let's talk about this. We are going to write a function with an f of x, so we're going to start with f of x. And if it wants it to go left 3, oops, that's the wrong color. Left 3, so we look up here, left. So where did that go? That goes inside with the x, and it's plus 3. Okay, so inside with the x will go to plus 3. And then it says up 1. If I want to go up 1, that would be a y. It's outside the parentheses. And outside the parentheses does what you would expect. So up is going to be plus. Next, if I want to shift the graph, again I've got my f of x. If I want to go right 2, is that going to be inside the parentheses or outside the parentheses? Left and right are inside the parentheses, so I'm going to have a 2. Inside the parentheses does the opposite, so instead of positive, I'm going to have negative. Okay, and then down 3 is going to be after. Any up and down is after the parentheses, and these ones do what you would expect, so that will have a minus. Okay, now instead of, we're going to kind of we're going to jeopardy this, so we're going to do it backwards. So inside here, I need to identify this translation. So the numbers are the transformations, so I have positive 2 and negative 5. Inside is right and left. Positive, up here, goes to the left. So this is going to go left 2. And outside, after negative, this is going to go down 5. So that's how you do shifts. So if I were you, now I think you should pause the video and try to do this next one on your own, and then restart and check. So if you are doing this one, inside we have a minus 8, so that's going to go left or right. Minus you would think is going to go left, but since it's inside the parentheses, it does the opposite. So that's going to go right 8. And after the parentheses, does what it says. So this is going to go up and 7. We're going to save that bottom part for day 2. So flip it over. We've got more to talk about over here. Sorry for the writing, you can kind of see through the paper there. Okay, so on this one, we are going to start out with negative f of x. If you have a negative out in front, that reflects your graph. So if it was like a u, that reflects it, and so now it will go like this. It'll be upside down. Reflects it over the x-axis. Okay? So if your negative is out front, it reflects it over the x-axis. And how we are going to do this is we are going to change the signs of our y coordinate. Okay, if your negative is next to the x, that's also a reflection, but this time it reflects it over the y-axis. And how we do this one is we change the sign of our x-coordinate. Okay, so let me show you kind of what that looks like. So if I have this coordinate here, whatever this is, x, comma, y. If I change the sign of my y-coordinate, this would still be positive, but now this would be negative. So it would be x, negative y, right? and then it would be down here, because I would still go over x, but now I would go down y. So see how that flips it over the x-axis, because this is the x-axis right here. This is the y-axis. So what if I change the sign of the x-coordinate? Well, I change the sign of the x-coordinate, it'll say negative x comma y. So I would go left x and then up y. So that one shifts it over, reflects it over the y-axis. So that's how those reflections are happening. Okay, next, if I have a number out in front of my parent function being multiplied, those are both happening here. So there's a number out in front being multiplied. Okay, so when that number is bigger than 1, that is what we call a stretch. A vertical stretch, sorry. A vertical stretch. So what a vertical stretch does, sorry, is it makes my graph taller and skinnier. And a vertical compression is when your a value is between 0 and less than or equal to 1. Okay, a vertical compression would make our graph shorter and wider. Okay, and we do both of these things by multiplying the y coordinates by the number, whatever a is, so the number out front. Okay, so now we've got more stuff going on. Lots and lots more stuff. Okay. So, on this, I need to write the function of each transformation. So I've got stretch vertically by a factor of 4 and reflect in the x-axis. Okay, so I'm going to have my f of x, because that's my parent function. Now where would a stretch vertically by a factor of 4 go? Okay, oops, I forgot to highlight that. So I'm going to go up here and find where it says stretch. So that's where it says stretch. And if I look over here, where do stretches go? They go in front of the f. So I'm going to put a times 4 out here. Then it says reflect over the x-axis. So which one of these reflections is over the x-axis? There it is. So it shows a negative sign out in front. So the 4 is being multiplied by f of x, so I can't put the negative in between there. The negative is going to go in front of the 4. So the negative will be the first thing, then any stretch or compression, and then the rest of your stuff. Okay, this next one, I have a compression of 2/7 and reflection in the y-axis. So my f of x, and I'm going to start with this compression. So a compression, go up here, compression, that also is out front. Now here, reflection in the y-axis. If I look up here on the y-axis, that's in front of the x. So my negative needs to go in front of the x. Then we're going to jeopardy this, so flip it around. So now we have the transformations listed like they are here, and we have to identify them in words. Okay, so everything that's not an f or an x or parentheses is a transformation. So this 52 is a transformation, the negative 78 is a transformation. Okay, now you might think this negative and the 3 is one transformation, but a negative out here is a reflection, and the 3 is something different. Okay, so I told you already that this negative is a reflection. Which reflection is it? Is it over the x-axis or the y-axis? When it's out in front, it is over the x-axis. If it were in front of the x, it would be over the y-axis. Now this 3 out here, that's here, one of these stretches or compressions. So is it a stretch or a compression? Well, you can tell by how big the number is. So is 3 bigger than 1, or is it between 0 and 1? It's bigger than 1, so we have a vertical stretch of 3. And right now you might be asking yourself, oh my gosh, I don't want to write out the word vertical. I'm sorry, you have to, because there is such a thing as horizontal stretches and compressions. We just don't cover them because they get all sorts of crazy in here. So we are going to put that off for later. So right now we're just dealing with vertical stretches and compressions. So either write a V stretch of 3 or just put vertical stretch of 3. You have to have a V or the word vertical so we know that it's happening vertically, which is what makes it either tall and skinny or shorter and wider, or smash it. So we're either stretching it like this or we're going to smash it like that. And then in here with the 52, that inside moves it left or right. And if you can't remember which one, flip back over to the front. Inside moves it left and right, and it does the opposite of what you think. So a plus sign we would think moves right, but it doesn't. It moves left 52. And then the 78 being outside moves it up or down, and it does what we expect. So down 78. Again, I think you should pause here and try to do this next one on your own. So go ahead and pause and try to do this one on your own. Okay, this 9/5 is out front, so it's either a stretch or a compression. So is 9/5 bigger than 1 or between 0 and 1? Well, 9/5 is bigger than 1. So this is a vertical stretch of 9/5. Then here I have a negative, so that's going to be a reflection, but I have to figure out which axis. Since it's in with the x, it's over the y-axis. And then lastly, I have this 87 here. It's after the parentheses, so that means it goes up or down, and up and down does what I expect, so positive is going to take me up 87 units. Okay, we'll save these bottom examples for tomorrow, or whenever we do that next video. So go ahead and flip over, and here's some old friends. So when we are graphing in slope-intercept form, there should be a y here. Sorry, that got cut off by the hole punch. So y equals negative 4x plus 3. Hopefully you know that to start this, you make a dot at the y-intercept. And remember, the y-intercept is the one that comes after the x. So the y-intercept in this case is 0, 3. To get there, I go over 0 and up 3. There's my dot. And then I need to, after that, use my slope. Remember, the slope is the coefficient of x, so my slope is negative 4. But I need to use rise over run, so I make it a fraction. So I'm going to go up or down 4. Since it's negative, I'm going to go down. Then I go right or left 1. Since it's positive, that's going to take me to the right. So I'm going to go down 1, 2, 3, 4, and right 1. Or if I felt like it, I could switch them both up and go the other way. 1, 2, 3, 4, up and left. So there's some points, and we graph that. Oops, I missed. With a nice straight line. Hopefully yours is a little straighter. I didn't have a very straight line. Okay, to graph the next one, this is in standard form. Every time we see standard form, we use the cover-up method. So I'm going to cover up the y first. So I see negative 2x equals 18, and I would divide, and I would get x equals negative 9. So my ordered pair has an x value of negative 9, but the y was covered up. So when the y is covered up, that means it's nothing, it's not there, so we put in a 0. To cover up the next one, I cover up the x, and I get 3y equals 18, and then I divide, and so y equals 6. Again, I had the x covered, so it's nothing, and there's the 6. Okay, some people are tempted to put these together. Don't do that. Here's why you can't do that. To graph these, negative 9, 0 is left 9 and up 0. 0, 6 is over 0 and up 6. And see, now I have 2 points to connect. Whereas if I drew this one, I would just have one point and nothing to connect it to. So make sure you make them two separate points and then connect them. Okay, last thing, we can use transformations to translate parent functions. So here's our first parent function that we're going to learn about. The first parent function we're going to learn about is a line. A parent function is the most basic function in the family of functions. So you don't see this very much, but the parent function is y equals x. You're used to seeing it more like this, y equals mx plus b, right? But this is the most basic, so it doesn't have an m or a b, it doesn't have any other crazy things. This one has a y-intercept at 0, 0, and a slope of 1. So it has the most basic things. We are going to move down here. I'm going to try. Nope, I can't. Okay, we'll just do this. Prop my paper up. Okay, so we are going to now use transformations to graph this in point-slope form. Okay, so our transformations don't ever have anything to with the y. So the first thing I need to do is get rid of that thing that's with the y. And since it's negative, I'm going to add it to both sides. Okay, so now I have y equals 2/3 times x minus 4, and then the plus 5 goes after that. Okay? So now my parent function is y equals x. So y is in my parent, the equal sign is in my parent, and the x is in my parent. So everything that's not y, the equal sign, and x has to do with the transformation. Okay? So it looks like my first transformation I encounter is this 2/3. 2/3 is outside the parentheses in front of it, being multiplied by it, so that tells me it's either a stretch or a compression. Remember, stretches are bigger than 1. This 2/3 is not bigger than 1, so it is a vertical compression. Okay, then inside here I've got a minus 4, so that is going to shift me, being inside the parentheses, right or left. Remember, it does the opposite, so it's going to shift me right 4. This guy out here, being after the parentheses, is going to put me up or down. It does what I expect, so it's going to take me up 5. Okay, so here's my parent function. Remember, we had a y-intercept at 0, 0 and a slope of 1. So we're going to up 1 over 1 all over the place. Okay. Okay, so there is that. Y equals x. There's my parent function. Okay, so what has happened is I had a y-intercept at 0, 0. I have to take that y-intercept and move it. Okay, let's start this right down. 0, 0. I have to take that y-intercept and do my transformations. So right 4, I'm going to add 4 to the x value. So this guy is going to get a plus 4. To move it up 5, I add 5 to the y value. So this little y value is going to get a plus 5. So what does that change my y-intercept to? Well, it changes it to 4, 5. So over 4, up 5, there we go. Then I have a new slope, which is my compression or stretch. So my slope is 2/3. So from here I'm going to go a rise of 2 and a run of 1, 2, 3. Or I could go backwards, down 2, left 3. Oops, there we go, okay. So you can see we moved from here, we moved over 4, up 5, and then we compressed it so it's going to have a not quite as steep slope. Okay, last thing. Write an equation of a line. Okay, so equation of a line is going to have y equals x. That's the parent function. Leave some space in between your equal sign and your x. That's the parent function, right? Y equals x, y equals x. Okay, so this says we've got some stuff going on. We have a reflection over the x-axis. So reflection over the x-axis, if we don't remember what that is, we flip over here and go, okay, reflect, nope, not that one, reflect over the x-axis. So what did that have? That had a negative out in front. So reflect over the x-axis gives us a negative out front. Then we have stretch by a factor of 2. Okay, so that's going to be 2 times, and it's also going to be out front. Then we have shift 7 units up. So up is going to be plus, and it's going to be at the end, a positive at the end, and then 8 units to the left. Left is positive, but it's in the parentheses with the x. Okay, so plus 8, this will be plus 7. Okay, so we're going to have our negative out in front, our 2 also out in front. Then it looks like the 8 needs to go in with the x and the 7 at the end. So I better put parentheses around here. Put my 8 in with the x and my 7 out at the end. Okay? So this is a reflection over the x-axis. This would be a stretch or compression. This one was a stretch. In here is right and left. Left being positive and right being negative. And out here is up or down. Up being positive, down being negative. And the other thing that we didn't have, that we could have had, is a reflection over the y-axis would have been right here in front of the x. Okay, good luck on your assignment.